Hello everyone. Over my next few tutorials, I like to give more accurate descriptions of how electrical resistance works, including an explanation of not only conductors versus insulators, like was discussed earlier, but also how wire diameter, wire length, and even wire temperature affect the resistance. In this tutorial video, I like to explain wire length and diameter specifically, as it is easier to explain, whereas the dependence of resistance on heat is more complicated. It should be somewhat intuitive / common sense that liquids flow easier through large diameter pipes than through small diameter pipes. So we can draw an analogy that electrical resistance is greater if the wire is thinner, aka the diameter is smaller. And we can also see that the longer the length of a pipe or similar conduit, the more overall friction the water will encounter in total, or whatever is flowing through the pipe. So the same exact logic should hold true for electrical resistance. Although when you study mechanics, the formula for water resistance is more complicated than just these two factors alone. With electrical resistance, it actually is this simple, where the only other factor you have to pay attention to is a special property of the material called resistivity, which is denoted with the Greek letter rho. It is important not to confuse these two concepts, however, because resistivity is a property of the material itself, while resistance is the resistance of the system in total and not just the material. So we conclude that, in terms of length and cross-sectional area, resistance equals resistivity times length over cross-sectional area. But we will see that this is not the full story when we investigate heat's effect on resistance in the next video. Don't forget to subscribe if you found this video informative, and make sure to see other tutorial videos, and follow me on either Facebook or Twitter for more content.